Hello all, we are here for the lesson number 31 of this VariCAD training course, and this lesson is called Creating Solids. So we are going to see about several commands to create solids. First, we need to see about how to create solids from 2D profiles. So you know already that we can use, and we will see about these options, we can use primitive solids, some other options, and probably the option that has more power, which is coming on the 2D side, make a profile, a 2D profile at your own choice and work around it to make solids on the 3D. Okay, so basically we need to see about this objects menu, the command solids created from 3D profiles, and we need to see about these functions inside. Okay, let us see first about full revolve and then the partial revolve, which are very similar. Okay, so basically I'm going to define, in this case, an open profile. I will do something without too much care, doesn't matter really. And I will say this. Okay, this is a 2D profile, open profile in the case. I can go to the command on the 3D side or on the 2D side, it's the same. So I will go here, full revolve, need to choose the profile, and if it is an open profile, the endpoints of the profiles are inserted already as the axis. Okay, so insertion point, it can be each one of those, and here it is, a full revolve, it's a 360-degree profile, very easy. Okay, I will delete this, we'll go again, but this time to the partial revolve, which is very similar, but in this case I can give an angle. I will say, for example, 120 degrees. Selected from endpoints, select profiles to rotate again, and insertion point, and basically, okay, 120 degrees partial revolve. Very easy also. For sure, these options could work with an open profile or with a closed profile. For example, we can do something like this, and I would need to have an axis. Okay, and if I do each one of those, it's the same, full revolve, a profile, and first point of revolving axis, second point, and done. Okay, it can be done to open profiles or to close profiles, exactly the same. Now we have another option which we can see here. Full revolve, partial revolve is done. Now the extrude. Okay, probably one of the most used commands when we are working with inserted profile. So we can use, I will use also this one, no big issues. So I can use this profile again, can go to the command either here on the 2D or on the 3D on the menu I've shown you. So extrude, I can give a height, I will give a bigger one. Okay, I can give the solid insertion point or not, and the axis direction if I want. I will not, I just say the solid insertion point, profiles, so this and this, it is a closed profile, in this case is needed. So now I give the insertion point, can be whatever I want, and it is done and inserted. Okay, very easy, no big problems. There is one other option also there with this exact same command. Extrude, again, whatever it is, draft angle for extrusion. I can say 3 degrees or whatever I want. Profile, give the same insertion point, and now you can see that it has a 3-degree angle in all the profile. Okay, like this, very easy also. Besides these commands, okay, we've seen full revolve, partial revolve, extrude. We have a function here which is called Prismatic Loft, and the Prismatic Loft will make a loft is a kind of evolution from one profile to another profile, and they should be closed because we are making solids, and the only limitation is that they need to have the same number of elements. Okay, so I will go again to the 2D. I can go, for example, to 2 rectangles, one and, for example, other. I will make some fillets. In this case I can put, for example, 10. Sorry. And the last one, 10. I can put in this one, for example, a smaller one, 5. Okay, and finally 5. Okay, now I can go to the Prismatic Loft. I need to give the solid height again. I can give the insertion point. It's the same thing. Base profile, it can be this one. This was chosen badly, so enter to finish. Insertion point, it can be, for example, middle point of this and this, and profile for the upper, for the top, this, and again I need to deselect this guy here. Okay, and what it happens is something like this. Okay, I will put on a top view, and the other view, it is front. So you see that the profiles, I go to the 2D now, okay, have the same placement as on the 2D. Okay, here's another option to work with profiles from inserted entities in the 2D. Okay, we have a couple of other options also inside this command, which are, for example, the coil and the helix. Okay, let us try to see the coil. The coil is very similar to the Prismatic Loft and basically creates a solid by lofting one profile to another, and at the same time executes a rotation. It can be an open profile, no big issue, and in case of it is an open profile, we need to give, also as we've done on the first command, on the revolve, we need to give a revolving axis. Okay, so the coil, if we go there, I'll go first and on the 2D side. So the coil if I go there, I can give a rotation angle. Also, I can define also the insertion point and the change smoother or just linear. Let us try to do something like, again, base profile and saying this is not. This can be, for example, the axis, and the top profile can be this one, deselecting this corner here and saying OK, and let us see and check what is the result. Okay, insert. So the result is something that first will go from one profile to the other. Okay, we'll take in consideration the distance from this profile to the axis and the distance from this profile to the axis. Okay, and this is what you can see when it does this. You see that they are not at the same level. Okay, they are not at the same level, and it rotates 145 degrees. In the case it was what it had, so it's a very nice function. Okay, this is the coil, very powerful, very interesting in some particular cases. Now I will show you the last option of this section, which is the helix, and the helix has several possibilities. Okay, let's try to show you the most important stuff inside. First thing is the helix is to make a kind what we can use for springs. Okay, I will use this kind of data. I will choose the profile as a normal section. I will give the helix height, the total height, the rotation angle, so it's 360, or this amount divided by 360. Instead of this I can give this, the number of threads and the radius, or take it out and do like this. It's as you want. So helix profile, this is a 2 mil radius, and right click, insertion point in the middle, and now there is a spring done. Okay, very easy, very nice. So you can work with this. We can work with this command on another way, which is, for example, axial section, and this can be useful for this kind of situation. Okay, so for that purpose I will try to draw something a little different. For example, triangular shape like this one here, and I can use the helix for axial section. I can give the same data here, profile. I can give this insertion point, and you can see the result, which is something like this. Okay, now for example I could make a cylinder like it was. I will use, for example, 15. I will choose a different color just to be a little more clear. Okay, and now just rotating it a little, minus 90, and the OK. So what I will do now, I'm not sure where it ends. Okay, it's not very important, just a very quick example. So cutting solid will be the red one, and the other will be something like this. So if and when you need to make something similar like this, for sure this is not a normal thread type. I had much care about the position, but I think it was interesting for you to understand what can be done with this. Okay, I think it's very easy. Also, just need to be careful with the data you give. There is one more possibility, which is when you go to the helix, you can use the profile is a radial section. So again, you can give this for this same data, helix profile. I will use this one here, insertion point. And what it does, for example, is a little more, in this case it was not the best profile to do this, but you can make this kind of part. Okay, it should be another better profile, but what it does exactly is it makes an extrusion and at the same time a rotation of a 2D close profile. Okay, it has some parts where it can be useful, but you must be careful with the kind of shape you use. It was not the best in this case, was not the best example, but I think you can see how can it possible to be used. Okay. So besides these possibilities inside this menu, we have another menu also inside the menu objects, which is basic solids, and we have a couple of commands here. I will show you all, but before I will do the more simple one, we still have one option here, which is loft rectangle to circle, that I would like to show you. It is important also to notice that I can assess most of these things either in 3D or 2D. If I access it on the 2D, as I've been doing until now, I have not this kind of question here. Okay, if I do it on the 3D side, it appears me like this. So I can go directly to the 2D if I click here or choose the drawing plan. It's the same thing done on a different way. So let us make an example, and probably I would need a circle. So I will make something around here, probably a little big, so trying to do something smaller, probably, okay, radius 20, more convenient. So now, loft rectangle to circle, 100 millimeters, okay, I think it is good. Base profile can be one or the other, not very important. When I'm choosing these profiles, I can use these two functions here, and for example, I can choose this automatic profile detection. So choose this first contour, this guy to this side, another click, choose wrong, so it made me a mistake. So I will deselect these ones here, and okay, bad choice. So let us start again with the basic function. It has this profile here and should have, but I can clean this so that we can use again the function. So again, so loft to rectangle, height, choose this one, here to this side, chosen. Okay, base profile, it is done. So okay, insertion point, I can give the middle point again. Oh, it has a problem also here, sorry, it still has a problem. So I will make choice point by point because it's checking this intersection and it's making a mistake. So insertion point, so midpoint of this guy and this guy, so in the middle. And I can have a rectangle also, or circle. So circle now and do the OK, and basically it will do me something like this. Very useful for air ducts and very nice function. Okay, so I think it's quite nice, this kind of feature in the program. So now let us see the easiest part, which are the basic solids. Sorry. And starting by the box. So height, width, length, these are the axes. Even so, it's not very important. And you must notice also that when you have these dialog boxes to insert a value, you can come to this little arrow and get the information you need from all these methods. Okay, not very difficult. So in the case a cube equal in all the dimensions, choose a solid color, just inserting it and do the OK, and it is inside. Very easy, the cube. Second one is it is a cylinder. Okay, so diameter, let us give it a little bigger, the length, and you can have these options: chamfer at beginning, at the end, or fillets, and considering the option you can give a value, for example 3 and 5, whatever you want. So now this is what it was not particularly good, this result. Let us redo it again and see what went wrong. So cylinder, chamfer, so two, little better. Okay, but very easy, it's graphical, so I think it's not difficult to work with. Next one, pyramid. It's also just saying all these dimensions. I will give some. So for example 50, wide 30, 20, 20, and in this case 10, something like that, and you'll get a pyramid. Okay, very easy, also not very hard to understand. Basic solids, the cone. So the length I will give also 100, diameter at the bottom 50, at the top 20. So here you have a cone. Next one, this one is done. And a pipe. The pipe is a kind of a cylinder, but with a hole in the middle. So length, outer diameter, inner diameter. Okay, I use these results, these values, and pipe, it is done. Okay, very easy also. Another one, cone pipe, the same stuff. Outer diameter 30, inner diameter 25, inner diameter at top, let's say 20 for example, and done. Okay, easy also. Following one, pipe elbow. So you can give an angle of the elbow, let us say for example the 90 degrees. Outer diameter, we can say that is 50 millimeter, inner diameter 40, radius in the center, we can say for example 30, and here it is. Okay, nice result and easy to get also. Following one, solid elbow, in this case the same, 135 for example, diameter 50, radius 35, the same as the previous one, but no hole in the middle, so get different result. And finally, to end, the sphere. The sphere has some possibilities. Let's make, for example, a 50 millimeter diameter. I would say no cuts, so round sphere, no issues, okay? But I can use these possibilities here. Cut at left, cut at right, whatever you want, I can use both. So for example, let us say cut at left, and let us say for example 20 millimeters and see what we get. So for example, this kind of stuff. And to be a little better and to make a very nice solid with this possibility, I can do both. So for example, I can say 10 on the other side, so in the end I will get this kind of solid, which is very nice in just one command. Okay, very nice. So basically I think I've shown you all the basic solids. I think very easy. I've shown you the basics of working with 2D profiles and insert them on the 3D environment. So next lesson we will continue to see about these functions with solids, but for now we are finished, and I hope that you can be with me again on the next lesson.